welcome back, and now we want to come up with a formula for gravity so that we are going to see if we can develop conceptually this formula for the force of gravity. And in order to do this, we're going to use a PhET simulation. So this is the PhET simulation gravity force lab. So see if you can find that on the internet. And let's look at the variables that are going to be involved. So we've got mass number 1, we've got mass number 2. We can control the amount of mass number 1 by moving this slider. We can control this mass by moving this slider, and then we can also change the distance between the two objects by grabbing it, and then we can also move the ruler around. So I'm going to put the ruler so that 0 is right underneath the blue ball, and then that way we can measure everything from the blue ball. Now up here is the force on mass number 2 caused by mass number 1. And over here is the force on mass number 1 caused by mass number 2. And do you notice that these two numbers are the same? So that's because of Newton's third law of motion. For every action, there's an equal and opposite reaction. So that if this blue ball is pulling on the red one, then the red one's pulling on the blue one with exactly the same amount of force. So having said that, just ignore this number over here and just concentrate on this number. So that's going to be the force of gravity. Now, our variables are going to be mass number 1, and then mass number 2, and then the distance r between them. But what we want to do is to try to come up with a proportion for this. Okay, so let's first look at mass number 1. What I want you to do is take the slider and move it so that you're doubling mass number 1. I want you to double mass number 1, and then I want you to look at how does this number up here change. So you might want to get on a scratch piece of paper and write down this number, and then double the mass, and then look at the number again and see what happens. Okay, did you do it? All right. So what we did was we doubled mass number 1. What did it do to the force of gravity? It doubled it. All right, so what does that tell you about the formula for the force of gravity? Okay, you notice first it's on the top part of a formula. It's not in the denominator, because if it had been in the denominator of a formula, then if this thing got bigger, this thing would get smaller. But it got bigger. Also, we can tell that our formula is not going to be m1 squared. So that's not the formula, because if that was true, if you had doubled m1, then 2 squared would be 4, and it would have 4 times the amount of force. All right, now you do it for m2. So if we were to take m2 and put it into this equation, proportion, where should it go? Do you think that it should go next to it? Do you think it should go underneath it? Well, what you're going to do is double mass number 2 and then see what happens to the force of gravity. And you will again notice that when you doubled m2, then what it did was it doubled the amount of force. So that's telling you that m2 should also be in the numerator of this proportion. Okay, so now what we want to do is, so we've taken care of this and this. So now somehow we need to incorporate r into our proportion. So how do you think we're going to do it? Well, this time, and you're going to keep m1 the same, you're going to keep m2 the same, but if this thing is on 2, so this is 1, 2, 3, and 4. So take this red ball and then move it until it's out here at 8. And then again, look at this number up here. So when we went from 4 to 8, what did we do to the r? We doubled it. And so what happened to the force of gravity? Well, first of all, did it get larger or did it get smaller? You should notice that the force of gravity got smaller. So that means that the r has to be on the bottom. Okay, but that's still not right. But we now know that the r is on the bottom because if the r gets big, then what comes out gets small. Okay, now to figure out exactly what this ought to be, we doubled the distance, and did you notice that this force up here was not 1/2? So if the formula had been divided by r, then if you were to double the r, then what would come out would be 1/2. But it didn't. So if you look at that number, you notice it's not 1/2, it's 1/4. So how can you get a 1/4 from this? You would need to take this and square it. Okay, so our final result then is going to be that the force of gravity is going to be m1 times m2 and then divided by r squared. So we have just derived that proportion. It's not an equation yet, it's a proportion. So in order to turn this thing into an equation, we need a constant of proportionality. And then that turns out to be big G. So this is called the gravitational constant. It's a fundamental constant of the universe that is determining the strength of gravity. And so this has been numerically calculated to be a certain number, and it's a fundamental constant of the universe. Now, as far as you're concerned, for me, in my class, don't worry about the big G thing. Okay, it's not necessary to solve the kinds of questions I'm going to ask you on the exam. But if you knew the distance r in meters, and if you knew m1 and m2 in terms of kilograms, then you would plug this big G in there, and then the unit that would come out would be newtons. So then this makes this into a metric formula, and when you include big G. Now, have you seen something else that looks like this? Okay, let's take a break. When we come back, we will discuss that.